All right, can you guys hear me? Okay,
Yes.
awesome. All right, so I'm going to go back to where we left off, which is this problem right here. It says determine the present value that must be invested into an account to have a future value A at a simple interest rate R after time T. And to do that, we have to use this formula right here. So I'm going to share my whiteboard. So actually, I had an idea. You could use the formula that I gave you the other time before we left off. And sorry, the Zoom cut us off, and we didn't have a complete conversation. But anyways, we're back on now. So instead of, you could use the formula I gave last time, or you can use this formula I'm about to give right now, which is more tailored to using your calculator. So I encourage everyone to use their calculator to solve this problem and not to try to do it in your head. If you're going to use your calculator, this is how you type it into your calculator. So this is kind of like a calculator formula. So the future value would be equal to P, then you open parentheses. Actually, we're solving for P. So P equals the future value A, open parentheses, and then you type 1 plus R times T, close parentheses, and you raise to exponent using this symbol here. And then you open the parentheses and you put a -1 and you close parentheses. Or actually, now that I think about it, there's an easier way. You could just divide right there and you'll be good. So you can type it in the calculator like this and it's just going to give you the perfect answer. You have to make sure you put the parentheses where you need to put the parentheses and you should be fine. Okay. So in this example, tells us that A equals 5,500 is R equals 10%. And also says T equals 6 years. Okay. So when we type this in the calculator, to find the P, you start with typing your A. So you do 5,500 divided by, and as soon as you do that, you open the parentheses, you do 1 plus your interest rate R. You have to make sure this is in decimal. So 10 divided by 100 is 0.1 times T, which is 6, and then you close parentheses, and this will give you the correct answer. So I'm going to share with you guys my screen on how I do that or how I type that on the calculator. I'm going to literally type it the way I wrote it down, the calculator. So 5500 divided by, then you open parentheses, 1 plus 0.1 times 6, close parentheses, you enter. So this is the present value, 3437.50. Okay. And let me explain a little bit about what this means. So for example, so basically you want to invest some money. You want a future value of A. You want to make $5,500 in the future. The future here is 6 years. In the next 6 years, you need your account to have 5,500. If you find an investment that has a simple interest rate of 10%, how much do you need to put in today so that by the end of 6 years, you have exactly 5,500? So you have to put about $3,437 to make that kind of money if the interest rate is 10%. That's what this means. So let's move on to the next question here. The next question here is not simple interest anymore, and this can be found in section 10.4 or 5 or something like that. So you can read more on that section, but I can just kind of show you the formula and you can just apply it. All the problems here, once you know the formula and you use it correctly, you get all the questions correct. So here it tells you to find the amount of money in the account after 4 years. So we're looking for the future value here. It's a compound interest problem. So I'm going to write out the formula on the whiteboard. So for compound interest, future value A is equal to P, open parentheses, one plus R divided by N, close parentheses. You have this symbol here, which is the exponent symbol. Then you open parentheses after the exponent symbol, and you type N times P, and you close parentheses. This is literally how you type it in the calculator. Okay. So P, open parentheses, 1 plus R divided by N, close parentheses, exponent symbol, open parentheses, N times T. Okay, and that's what I'm going to use to solve this problem. Now, P is the principal, R is the interest rate, N is called the compounding period. Okay, it represents how many times you compound your money per year. It's going to be given in the problem. Directly though, it may not tell you this is the number of times per year your money is being compounded. I'll give you an example for N. So when N is when it says semi-annually, means that N is 2. Okay, semi-annually means N is 2. Annually means once a year. So in this case, it means that N is equal to 1. If it says quarterly, there are 4 quarters in a year. So when your money is being compounded quarterly, it means it's compounded 4 times a year. So N will be 4 in that instance. If it says monthly, 12 months in a year. So that means your money is compounded 12 times a year. So your N will be 12. If it says daily, well, we're going to assume that there are 365 days in a year. So that means your money is compounded 365 times a year. So these are the common compounding periods that we have. So back to my screen, my main screen. You look at this problem. It tells you the P is $7,000. R is 5%. In decimal, that would be 5 divided by 100, which is 0.05. The compounding period is semi-annually, which means n is equal to 2. T is 4 years, so T equals 4. So you punch those numbers in the formula I just gave you guys. And so I pull up my formula, my calculator here. And the formula I told you, you start by putting in your P. We start by putting in the P. P is 7,000, so 7,000 7,000. Then you open the parentheses. You type 1 plus R. R is 5%, so in decimal that is 0.05 times N, sorry, divided by N, right? Divided by N. N in this case is 2 because this is semi-annually, so N is 2, so you divide by 2. Then you close parentheses. And then you do the exponent symbol. The exponent symbol is right there. Everyone should have this on their calculator, maybe in a different spot on your calculator, but try to make sure you have this. It's very important you have it on your calculator. Otherwise, you may be able to do this problem. So some calculators are more fancy than the others. Mine looks like it's fancy. So once you do my exponent, it actually shows exponent symbol. And once you have that, you open the parentheses and you type in N times T. N is 2 times T, which is 4. And you close parentheses. And then you enter to find the result. So in this case, the amount of money is 8528.2, 2 decimal places, 8528.82. Okay. So the principal is the amount you put in today. So you put $7,000 today. And after time T, after 4 years, you have more money, over $8,000. The next question is asking to find the amount of interest was earned. Well, if you started with 7,000 and you ended up with 8,528.82, definitely you made some money. The money you made is found by subtracting to find a difference, right? So you, in your future value, 8528 rather, 8528.82 minus 7,000. It gives you 1528.82. 1528.82. Now we can check to see that that's correct. Next question says, how much money should be deposited today in an account that earns 5% compounded semi-annually as well, and so that it will accumulate $8,000 in 3 years? So in the previous problem, trying to look for the future value, and they told us it was 7,000 in the beginning. This one, telling us what the money wants to be in the future, what you want in the future, and it's asking what do you need to put in today. So here we're solving for P. The formula is going to be slightly different, so I'm going to give you the formula for that. So back to my whiteboard. For P, still on compound interest, the formula is A open parentheses 1, or actually A divided by open parentheses 1 plus R divided by N close parentheses, to the exponent, open parentheses, n times t, close parentheses. So if you type it this way on your calculator, it's going to give you the final answer. Okay, so I'm going to type this just the way I wrote it down on the calculator for this problem. So we start with A, which is the future value. In this case, the future value is 8,000. So you type 8,000. And then you do divided by, then you open parentheses, 1 plus R, which is the interest rate of 5%. So in decimal, that is 0.05. Divided by N. This is semi-annually, so N is 2. Close parentheses. And the next thing is the exponent symbol. And then you open parentheses after that to put N times T inside. So you do N, which is 2, because it's semi-annually again, times T. And T is the number of years. This is $8,000 in 3 years. So T is 3. And then you close parentheses. And as soon as you close parentheses, you can enter to find the answer. If you accidentally omit one of the parentheses, it's going to give you an error, or it may give you a wrong answer. So you have to be careful when you're typing things in. This exam is more of being careful because you have all the formulas, you're taking this exam from home. So nothing is really stopping you guys from getting 100%, except you just have to be careful when you type things in. So it is rounded to the nearest cent. So this is 6898.37. 6898.37. That's correct. Number 15. So this is a new topic. So we're done with compound interest. We're moving to what is called annuities. And basically, an annuity is kind of like the opposite of a life insurance. It's kind of like the opposite of life insurance. I know majority of you guys know what life insurance is, so I don't have to spend time explaining that. But basically, just like a life insurance is you trying to insure your life, basically, in case something happens to you and you pass, you get a benefit, or your family members get some sort of benefit. And when you buy life insurance, you're basically betting that you may die earlier than you thought, right? You may die early. And in case you die early, your family do not get to suffer the consequence. That's the whole point of buying life insurance, right? Well, annuity is the opposite of that. So you buy annuities because you're not afraid of dying early. You're actually afraid of living too long. So if you live too long, you may outlive your money, and you get old and broke. So that you don't get old and broke, you buy annuities. And what it does is, once your money is annuitized, you start to get a certain amount of money every month for the rest of your life. So even if you live too long, you still getting that constant paycheck until you die. The money wouldn't stop. It's kind of like your 401k. Your 401k is an annuity, because when you retire, you get your pension or whatever it is constantly for the rest of your life. And as soon as you die, it stops. It's kind of like the opposite of life insurance. So if you have an annuity and you have life insurance, you're insured both ways. But anyways, to compute the value of annuity, here on the test, the good thing is, on the test, it shows you the formula for annuity. And so if you click the icon here, and it says click icon to show the formula. So I click that icon, and I'm just going to bring it down here. Can you guys see the formulas? Okay. So the thing is, it doesn't tell you which of these three formulas is the right formula. Okay? Now, this is compounded quarterly. So n equals 4. The formula in the middle is the right formula. Now, on the exam, when you see this question, you always use this formula, one in the middle. Don't use A. Use this formula here, the third formula. And don't even try to use the first formula. This may work sometimes if n is 1, but this is the formula for annuity. Okay? Now, watch the way I'm going to type it on the calculator. So the way you type this on the calculator, you start with P. In this case, P is your periodic deposit, which is 1,500 given the problem. So you type 1,500. There's a bracket here after P. Please do not type bracket on your calculator. If you type brackets, it's not going to work. You're going to get error. So a bracket is still the same thing as a parentheses. So instead of brackets, we're going to type open parentheses. And then after the bracket, there's another open parentheses right after. So we'll type open parentheses a second time. And after that, you have 1 plus r divided by n. So you type that 1 plus r. R is the interest rate. This is 7.25%. So in decimal, type the decimal value of that. So that's 0.0725. And divided by n is 4 because this is quarterly. And after dividing by n, you close the parentheses. You notice there's an exponent here of nt after the close parentheses here. So you do your exponent symbol, you type exponent. And if you're using a scientific calculator, you may not work this way, but you may not see the same thing you see on my screen. Just follow the instruction, type by type, and you get it right. So after you type the exponent symbol, you type the exponent. Well, please make sure you put the exponent in parentheses. So you open the parentheses after the exponent. You type n times t and you close parentheses. So n times t, n is 4, t is 7, you close parentheses. So now that I'm done with the exponent, there's a subtraction of 1. So you type, come down from the exponent. So you subtract 1. After subtracting 1, there's a closed bracket. We use close parentheses instead. And that's just the numerator. Now you're going to have to divide by the denominator. And the denominator starts with the open parentheses. So you open parentheses, and you do r divided by n. That is 0.0725 divided by 4. And you close the parentheses after that. And you're done. So that's what it tells you the answer is. It says round it to the nearest dollar, so we make it a whole number. So 54091. Now to find how much interest you've made. So at the end of 7 years, you have an annuity that is worth $54,091, right? You made that money by depositing 1,500 at the end of every 3 months, pretty much at the end of every quarter for 7 years. to calculate the interest, let's calculate the total money you put into you deposited, right? So you deposit 1,500 every 3 months, pretty much 4 times a year, so times 4. So when you multiply by 4, you get 6,000. That's the amount you deposit each year. Then you deposit that for 7 years. You multiply 6,000 by 7. That gives you 42. So you've put in $42,000 total. But then you ended up with 54,000 some change. So how much extra did you make? That's the interest. So you subtract 54,091 minus your total contribution, which is 42,000. That brings it to 12,091. Now, this one is also still annuity, still dealing with annuities. It's more of kind of like financial goals. So it's kind of the reverse of what we just did. In the previous problem, you had a periodic deposit, and you wanted to find how much you're going to end up with at the end of 7 years. This is a different case in the sense that you know what your financial goal is. So let's say your financial goal here is $220,000 at the end of 15 years. So let's say you need $220,000 in the next 15 years. The question is, how much do you put in each month today, starting from today, for the next 15 years, so that you end up with this goal, you meet your goal. And to do that, you can click the icon to get the formula. So here we're looking for the periodic deposit. So this one says P equals. So this is the formula that we need for that. And I'm going to try to rush through this. So you type all of that stuff. You start with A, open parentheses, R divided by N, close parentheses. Then you divide. Then you have an open parentheses, another open parentheses, 1 plus R divided by N, close parentheses, exponent of NT. But you put your exponent, make sure you start with open parentheses and close at the end. And then you subtract 1 and then you close again. So it's a lot of stuff you have to learn. You have to master typing this on the calculator. I would encourage you to go to the homework and practice typing these formulas on the homework first. And if it's working for you perfectly well, then you know that on the exam, you'll be fine. Or on the review, you can try it yourself and see how well it works. Again, I'm running out of time. 4 minutes. I have 4 problems. So I don't think I can finish this set of problems. We may have to reconvene again. I'll probably put it for the next 10 minutes. So that we don't spend too much time. We're almost done. But again, I don't want to rush this. So let me see how far I can go with typing all of this stuff. So I'm going to start with A. Right? So P equals A is the future goal. That's 220,000. 220,000. And then you have an open parentheses, R divided by N. The R in this case is 4.5%. So if you divide 4.5 by 100 to convert to decimal, you have 0.045. Actually, sorry. I didn't put multiplication. Times 0.045. Actually, supposed to open the parentheses. Okay. I'm trying to rush. 220,000. Open parentheses. R, which is 0.045 divided by N. And here it's compounded monthly, so N is 12. There are 12 months in a year. And after that, you divide, which is this long line here. We're done with the numerator. Now the denominator starts with 2 open parentheses. So open parentheses and open parentheses again. Then you have 1 plus R, which is 0.045 divided by N, so divided by 12, close parentheses. Now I have to do the exponent and put N times T inside that. So exponent. Anytime you do your exponent, I suggest you always start with the open parentheses. So you do N times T. So that's 12 times T. T is the number of years. In this case, it's 15 years. So times 15. And close that exponent. Close that. And after that, we can subtract 1. Subtract 1. Then close parentheses again. And we enter. Now, this is what it says. 8957.985. It's asking how much do we put this to the nearest dollars. Now, when you do this problem, make sure you always increase this to the next dollar. So this is 857. I'm going to put 858. 858. And I'm doing that not because this is 98 cents or 99 cents, it's the rounds. No. Even if this was like 5 cents, I'm still going to increase this by $1. Your financial goal, you always make sure you round up, never round down. That's the periodic deposit. It says how much of the 220 comes from periodic deposits. So I'm going to take that number I just typed in, 858, and I put this is the periodic deposit each month. So in a year, you multiply by